So if we're going to solve equations with variables on both sides of an equal sign, we need to be able to consolidate this equation. So we have 2 plus 5k equals 3k minus 6. We have to get the letters on one side and numbers the other. So if I'm going to get this letter over here, I'm going to change its sign. By doing that, I then get 2k equals negative 6. And then I have to move this number over. So this would be a minus 2. So I get a negative 8. And now I can divide by 2 to get my answer, which is negative 4. So same thing with this equation. I have a 7w. So I'm going to move the letters so they're on one side and the numbers on the other. So if I move the 3w over, so let me write that. I'm going to move this over. I'm going to subtract it, which gives me 2 equals 4w. And then I can divide by 4 to get my w by itself. And this is just a fraction of 1/2 when it's reduced. And there's the answer. Sometimes problems have grouping symbols that we have to deal with. Groupings are parentheses. And so we need to remove the parentheses. So I'm going to distribute this problem. So 6, 5m minus 3 equals, and then we have 1/3 24m plus 12. So what we want to do is remove the parentheses by distributing. So 6 times 5 is 30m. And then we have to make sure we multiply both of them. So we get 6 times negative 3, which is negative 18. And then 1/3 times 24 would be 8m, because 1 times 24 divided by 3. And then same thing, 1 times 12 divided by 3 is 4. So I've removed the parentheses. Now I'm going to get the letters. So I'm going to move this letter over here, which gives me 22m minus 18 equals 4. And now this is just a two-step problem, so I add 18 to both sides. I get 22 on the right, 22m on the left, divided by 22, divided by 22. I get my answer as m equals 1. So we have this next problem where we have 8s minus 10 equals 3, and then there's parentheses, 6 minus 2s. So first we have to do is remove the parentheses on the right hand side. This side, nothing happens to it. But this side I have to distribute. So I get 18, and then 3 times a negative 2s is a negative 6s. Now I can move my letters to one side by changing the sign. This gives me 18 equals, and this happens to be 14s minus 10. So then I add 10 to both sides to solve my two-step equation. That's 28 equals 14s divided by 14, and s equals 2, and I have my answer. So let's solve these equations doing what we know so far. So I have a 5x plus 5, nothing there, but I have parentheses, so I'm going to go ahead and multiply that out, 15x minus 12. Minus 10x is not in the parentheses, so I don't multiply it. Now I'm going to combine my like terms on one side before I do anything. Combining does not mean changing the sign, so 15x and a negative 10x is really a 5x. And now I have a problem that I can move my variables to one side. And when this happens, you'll notice that I get 0. So the letters disappear. And so I end up with just a 5 equaling a negative 12, because this is 0 also. When you have this kind of special problem, that's what we're doing, special solutions. When they don't equal each other, you have what's called no solution. So oftentimes it's represented with this empty set. So let's do this problem. I'm going to go ahead and multiply the 3 times the 2, which is 6b, and 3 times the negative 1, which is negative 3, minus 7. Notice the 7 doesn't get multiplied because it's not in the parentheses. So now I have my 6b minus 10 on the right-hand side. I'll combine my like terms. These two are like terms, so I just combine them. So it's becomes 6b minus 10 equals 6b minus 10. And I'm going to move my letters over. So here's my minus 6b. And this time, I also get 0 again, so this becomes 0. But I have a negative 10 on the left, and this is 0, so I get a negative 10 on the right, because that's 0. Now I get a true statement. Negative 10 does equal negative 10. So when they're identical, and you could have noticed that on the top here, that they were identical here, but if you don't, they're identical down here, then you have what's called all solutions. So unlike the problem over here on the left, they were unequal, so we have no solution. And then in this problem, they were equal, so we have what's called all solutions.